Thanks for inviting us to be here today. My name is Alex. I'm with the U.S. Bureau of Labor Statistics, and I'm joined today by colleagues and friends Krystyna and Marta from Statistics Poland. Together, we are part of the machine learning project under the UNECE high-level group on the modernization of official statistics. And we are tasked with, among other things, answering the following questions. Is machine learning useful for official statistics? And if so, how should we do it? If you don't know the answer to the first question, the answer is yes, machine learning is very useful for official statistics. And as part of this project, we have documented a number of examples of this, but let me give you just one. Each year, the Bureau of Labor Statistics collects hundreds of thousands of written descriptions of work-related injury and illness, which we then read through and code to indicate things like the occupation of the worker and the characteristics of the injury or the illness. 7 years ago, we did this coding entirely by hand in a very time-consuming process that took about 12 person years of labor to perform each year. This past year, we did more than 85% of this automatically using machine learning. So machine learning not only allows us to automate this work, but it turns out the machine learning also performs this work more accurately than our trained human staff. And machine learning is useful not just for these coding and classification tasks, but we're now also using machine learning for record matching and automatic error detection. There is a catch, however. If machine learning is so useful for official statistics, where is it? And the reality is that if you look at most statistical agencies, even statistical agencies which are already using machine learning to some degree, there is a lot more talk about machine learning than there is actual production use of machine learning. And one of the reasons for this is that there is a severe lack of skills and knowledge needed to implement these systems into production processes. So a big part of what we're doing with this group is trying to address this skills gap. We're doing this in a number of ways. We've launched a number of pilot projects in different areas of machine learning, including text classification, editing and imputation, and analyzing imagery. We are conducting research on the evaluation and quality metrics for using machine learning in official statistics. And we're also engaging in a number of information sharing activities, including conferences and workshops and tutorials. So you will have to wait probably until later this fall for full reports on all of these activities. But until then, we have a sneak peek, a sneak preview of some of the work that's being done by our friends at Statistics Poland. And I will now turn it over to Krystyna and Marta to share that work.
Okay, so thank you, Alex. Good morning. My name is Krystyna Piątkowska, and I'm working in the Data Engineering Department in the Statistical Office in Poznań. And in this project, I am working on the COICO classification. I wanted to say a few words about the process of our self-training in the UNIS project and the ideas that we developed that we observed during this project. At the beginning, we had only basic knowledge about machine learning. We knew that this is the situation that computer algorithms learn how to solve problems. We also knew some algorithms, but we had no experience with machine learning classification. And that was when we saw the script shared by Alex, and it was our first inspiration. We could find there the basic few steps how to start with machine learning classification. Then we learned a lot from the internet, from tutorials, courses, and documentations. But we also found that people from many organizations meet the same problems when they start with text classification. We could observe the first steps of the team from Serbia or IMF, and we could notice that the first step can be the most difficult one. We found that every team working on classification problem could be inspired by the same few lines of code. And it was the inspiration to prepare the very basic tutorial on Colab. Only a few steps, the very small data set, 60 sentences in 3 different languages, and everybody can only click some buttons to classify those sentences. It was tested by the people without any experience with programming, and they said that this is very easy. In the tutorial, there is only one method and default hyperparameters, but it is a good first step into machine learning algorithm. And now I'm going to show quickly the tool. The first step, you have to import all the Python libraries that you need in your classification, and then read the Excel file to the data frame. The next step, you have to divide your data set into train and test group and vectorize it. And the next step, you have to choose the classifier. In this case, this is logistic regression, and we train it with our X and Y train data. Now we are ready to test our classifier with the X-test data, and we can save all the results in one data frame to see the sentence, the correct category, predicted category, and the probability of the prediction. We can also see the classification report with precision, recall, F1 score, and accuracy. In this case, accuracy is 61%. It is quite low, but the data set was very small, only 60 sentences, and the test group here in the supported certain, it's only 18 sentences. You can also check it on your own sentence. Then you have to, the written sentence change in the vectorized list, and you can use your classifier to predict the outcome. And we have you have written the sentence, good morning, this is the sentence to test the machine learning algorithm. And we predict that this sentence is in English with the probability 94%. And that's all about the tutorial. We have shared also 4 machine learning methods with hyperparameter tuning and more detailed analysis on the GitHub of Statistics Poland. It can provide some help for people that want to take the next steps in machine learning. We have invented also some other tool to convince people to use machine learning, and my friend Marta is going to describe it. Thank you.
Thank you, Krystyna, for the introduction. My name is Marta Kruczek-Szepel, and I'm working with Krystyna in data engineering department at the statistical office in Poznań. Yes, as Krystyna mentioned, the whole process of gathering our results was a mix of self-education and gathering information we found into existence. As soon as we received our first satisfying results, we thought what if there was a tool to automate our classification. We knew that somewhere in Poland or even in Europe, there were teams in official statistics who were dealing with this kind of job on a daily basis in a manual way. And this was the moment when we thought that it's a good occasion to invent a tool that can help our colleagues and that can be implemented pretty fast and really easy to serve. And now I'd like to present you, excuse me. I'd like to present to you this very briefly. So this is the main layout of this application. The current version of the application has got several functionalities, like choosing the way of classification. It means that we can download the product name list from the file, or we can just simply classify our product name just by entering the name into this placeholder. The other functionality of this application is choosing the classification method. We used 4 methods in our project, and user can pick one from them, for example, random forest, naive Bayes, etc. And in the output, we receive a result table with the information about category prediction for each product we entered, echo codes, and the level of probability. The other very important feature of this result table is the possibility to edit our records. So if auto-coded category isn't the proper one, we can change it into another one and save it. And if the user consider that any table row is unnecessary, we can just delete it. And the best and practical aspect of this application is the fact that we can save our results into XLS or CSV file. So in fact, we can share our results in a pretty fast way with anyone who is working on the same project, or leave just our results for our future comparisons. We think that this tool is nice and very easy to use, and the best thing in this is the fact that all the machine learning techniques, all the mathematics are hidden behind a very friendly interface. So actually anyone with no programming experience can make use of it, and just no coding abilities are required. So it's really easy to learn and to understand it. Yes, so summarizing, all the tools we told you about and realization of such projects like UniC Machine Learning Project are very important measures to encourage people and institutions to experiment with new technologies and show that using machine learning methods can be quite simple. This is a very first and relevant step into developing modern solutions in official statistics. People are more open to new methods if they know at least if they have at least the basic knowledge about. They know that there's nothing to be scared of. And one more thing we would like to highlight is the fact that here in UniC Machine Learning Project, we found also an inspiration for sharing our knowledge with other project members. The project leader managed to establish a web page where any member can get familiar with the scripts and reports prepared by other project members. And we did the same. We published our code on GitHub page, and we prepared a detailed report on our work. Yes, so coming to conclusion, we think that, yes, alternately training and sharing are a very core keys of success. Yes, so thank you.